Right now, pull out your phone and send someone a message across the entire planet. It arrives in half a second. You feel nothing. You expect nothing less. Now go back to the 20th of July, 1969. A man is standing on the moon, 384,000 kilometers from your living room. He wants to say one sentence to you, and the radio carrying his voice is weaker than a whisper. By the time that voice reaches Earth, it is a flicker of energy almost too faint to exist. And somehow 600 million people heard it at the exact same moment. So how did Apollo actually talk to Earth from the surface of the moon? The answer is not the rocket. Everyone remembers the rocket. The real miracle is the invisible thread that connected two worlds and never snapped. It runs on 20 watts of power, the same as a dim light bulb on your desk. By the end of this, the message you just sent will feel like science fiction. Let's follow the signal. Start with the distance, because the distance is the whole problem. The moon sits about 384,000 kilometers away. You could line up 30 Earths in that gap and still have room to spare. Radio waves cross that gap at the speed of light. Nothing in the universe travels faster. And even at that impossible speed, the trip takes about 1 1/3 seconds each way. So Mission Control asks a question. It flies to the moon. The answer flies back. From question to answer, 2.5 seconds of pure silence. Listen to any Apollo recording and you can hear it. A beat of nothing before every reply. That pause is not hesitation. That is the speed of light made audible. Now some of you are thinking the delay must have ruined every conversation. It did not. Both sides simply learned to wait, the way two people on a long-distance call still do today. But the delay was the easy part. The hard part was hearing the voice at all, because by the time it reached Earth, that voice had almost nothing left. Here is a number that should not be possible. The transmitter on the spacecraft put out about 20 watts of power. 20 watts. That is a dim bedside lamp, a nightlight, not even a real light bulb. Now take that tiny glow and aim it across 384,000 kilometers of empty space. A radio signal spreads out as it travels, getting weaker with every kilometer. By the time it arrived, the signal was down to a trillionth of a watt, picowatts. Imagine a single drop of water and then splitting it 1 trillion times. That is how faint the voice from the moon was. This sounds made up. It is verified physics, written into every NASA link report from the era. A whisper across a room already fades to nothing in seconds. This was a whisper across the solar system, and Earth was somehow listening for it. If picking up that whisper sounds impossible, good. That is exactly the part NASA does not put on the posters. So subscribe before we get there, because the next part is the trick that made it work. Because catching the whisper was only half the challenge. That single faint signal had to carry far more than just a voice. Think about everything Earth needed to know from a crew on the moon. They needed the astronauts' voices so they could talk. They needed live television so the world could watch. They needed telemetry, hundreds of tiny readings about the spacecraft's health. They needed the astronauts' heartbeats and breathing, beamed live from inside their suits. And they needed to track exactly where the spacecraft was, to the meter. 5 completely different jobs, and only one fragile 20-watt signal to carry them all. So NASA built something elegant. They called it the Unified S-band. Instead of 5 separate radios fighting for room, everything rode home on one carrier wave. Voice, television, data, medical, and tracking, woven into a single braid of radio. On Earth, the receivers untangled the braid and split it back into 5 clean channels. It was so well designed that the basic idea still shapes deep space communication today. One clever signal did the work of 5, but a signal this weak still needed something enormous to catch it, something the size of a building with one ear pointed at the sky. To catch a whisper from the moon, you need a very, very big ear. NASA used dishes scattered across the entire planet, one in Goldstone, California, one near Madrid, in Spain, and dishes in Australia. Here is why 3. The Earth never stops spinning. As the planet turns, the moon slides out of view for any single dish on the ground. So as one dish loses the moon over the horizon, the next one is already rising to catch it. They pass the signal between them like runners in a relay, so the link to the moon never broke. And now, stop and really sit with this. We remember the rocket, the fire, the launch, the giant leap. But the rocket only got them there. The real impossible part was this. We took a whisper too faint to register, and we heard every word of it, live, on the first try. The rocket was raw power. This was raw genius. And the genius is the part we forgot. Could you have built a machine to catch 1 trillionth of a watt from another world? Tell us honestly in the comments. Because catching the signal was one thing, keeping the voices from turning into chaos was another. Picture mission control. Dozens of experts, every one of them with something urgent to say. If they all keyed their microphones at once, the crew would hear nothing but noise. So NASA made a strict rule. Only one person ever speaks to the crew. They called that person Capcom, the capsule communicator. And Capcom was always another astronaut. One trusted voice the crew already knew, so no order ever got confused in the heat of the mission. When Apollo 11 touched the surface, it was Capcom Charlie Duke who answered. Through a flood of static, the crew said, "Tranquility Base here. The Eagle has landed." And Duke, almost too rattled to speak, replied that they were turning blue. Everyone could breathe again. But one place could break even that single trusted link. The far side of the moon. Each orbit, the command module swung behind the moon, and the moon's own body blocked the radio completely. For about 45 minutes, every single orbit, there was nothing. No voice, no data. Total silence. Mission Control could only sit, watch the clock, and wait for the spacecraft to come back around. And when the signal finally crackled back to life, the whole room would erupt in relief. Now for the hardest thing they ever asked that little signal to do. Live television. A television picture needs far more information than a voice. It is a flood of data. The lunar camera could not send a normal broadcast picture. There simply was not enough signal, so they used a special slow camera, sending fewer frames, scanned slowly to fit through the narrow signal. It was a clever trick, but it had a cost. The lunar picture did not match a normal TV at home, so on Earth, engineers had to convert it on the fly, pointing a regular TV camera at a special screen. Every conversion lost a little quality. The crisp picture from the moon turned soft and grey and grainy, and then, decades later, a heartbreaking discovery. The original high-quality tapes from the moon, the cleanest version ever recorded, had been lost, reused, erased, or simply misplaced over the years. The best picture of the most famous moment in history, gone. What survived is the grainy version the whole world saw live, the faint one, the human one. 2 stations in Australia caught that first picture. A small dish at Honeysuckle Creek saw it first, then the giant 64-meter dish at Parkes locked on, and the picture suddenly got clearer. Houston switched to the Parkes picture and stayed with it for the rest of the moonwalk. That single grainy feed was about to reach more eyes at once than anything in human history. So picture it, the same warm summer night, all across the planet. In living rooms, in bars, in shop windows, on screens set up in public squares. An estimated 600 million people, 1 in every 6 humans alive at the time, all of them leaning toward the same soft, grey, flickering picture at the very same moment. And here's the part that gives me chills. Every single one of those people was watching a whisper, a trillionth of a watt, turned into a face on a screen. The faintest message ever sent became the most watched moment in history. Strangers who shared no language, no country, no flag, all looking up at the same idea. You close your eyes and try to feel it, the whole planet holding its breath in the dark. 600 million people listening to the same fragile signal cross the same impossible dark. For a few minutes there was no them and us. There was only this picture and the silence around it. A whisper from another world and an entire species leaning in to listen. Then the moment ended. The crew still had to come home. And coming home meant going silent one more time. Returning to Earth, the capsule slams into the atmosphere at enormous speed. The air ahead of it compresses so violently it turns into a glowing sheath of superheated plasma. That fiery shell is beautiful. It is also a perfect radio blocker. For about 3 to 4 minutes, the plasma seals the capsule off completely. No signal in, no signal out. On the ground, this is the communications blackout, and it is terrifying. Mission Control has no idea if the heat shield held. If the crew is alive, they simply wait, listen to the recordings, and you can hear Capcom calling the crew over and over into nothing. Apollo, do you read? Apollo, do you read? And only static answers. And during Apollo 13, when the spacecraft was crippled, that silence was almost unbearable. Then, right on schedule, the static breaks. A voice comes through, the crew is alive, and the whole room finally breathes. Every part of the journey had its silence. Behind the moon, through the fire, and the longest gap of all. The plain, vast, ordinary silence of 384,000 kilometers of empty space. And across every one of those silences, that fragile thread of radio held, every single time. So how did Apollo talk to Earth from the surface of the moon? With 20 watts of power, the same as the dim lamp on your desk. across 384,000 kilometers in a little over a second, through one elegant braided signal that carried voice, pictures, and the very beat of a human heart. Caught by giant ears around the world, passing the whisper hand to hand as the planet turned, and carried, at the very end, by one grainy grey picture into 600 million pairs of eyes. Tonight, you will send a message across the planet without a single thought. It will arrive in half a second. You will feel nothing, and that is the real miracle. Because every time you tap send, you are using the children of that 20-watt whisper. The same physics, the same speed of light, the same fragile thread, just grown stronger. They aimed a whisper across the dark and prayed that someone would be listening. You aim a message at the planet and never once doubt that it will arrive. They trembled in the silence, waiting 2.5 seconds for an answer from another world. You get annoyed when a reply takes more than 2 minutes. The next time your message arrives, the instant you send it, remember where that magic came from. It came from a dim light bulb on the moon and a planet that built giant ears just to hear it. The whisper crossed the dark, the thread held, and for one night, the whole world listened together. Next time, how the astronauts on that mission actually went to the bathroom in space. If this gave you chills, you know what to do. Like and subscribe so the next signal reaches you too. And tell us in the comments, would you have trusted a 20-watt whisper to bring your crew home? Good night, and the next time you tap send, listen for a moment. Somewhere out there, a thread is still holding.